So here's a quick demonstration of alerting with Sios DataKeeper. So we have a two-node cluster configured with two servers, SQL1 and SQL2 in a cluster, and just a simple resource, empty resource with just a DataKeeper volume configured in that resource. So I'm going to start by showing you some alerting functionality should a service fail. So we're monitoring this Sios DataKeeper service. So if we simply restart this service and we check our email, we'll see two emails come in. First one comes in from SQL1 that says the service entered the stop state. And then the second alert comes in from SQL1 that says the DataKeeper service entered the running state. So that'll happen automatically should the DataKeeper service start or stop on either system. And we see if we look at SQL2, we can do the same thing over here. We can stop the Sios service. So this time I'll simply stop the service. And let's check out the email. So we get an email come in from SQL2 that says the service entered the stop state. And then once we go ahead and start that service back up, we'll get another email that says the service has entered the running state. So that's monitoring the DataKeeper service. As we saw earlier, we also have the ability to be alerted should the recovery point objective exceed 5 seconds. So in order to see that, what I did with the DataKeeper job is I actually specified a maximum bandwidth so we could make the async queue grow quickly. So with that set there, I'm going to jump back to the source of the mirror. Here we are. And I have a disk speed test I'm going to run. And we're going to look at perfmon and watch the async queue grow. So let's check out perfmon. Here's the queue current age, which is the recovery point objective. We'll see it starting to grow here. Hopefully it will actually grow. It's keeping up pretty well. Let's give it a second. There we go. Well, we gotta get up over 5,000. We might have to run this again. Let's run it one more time. We usually get it to grow here. Here we go. It's growing and growing. Here we go, shooting up. Let's get over 5,000. There we go. Hit 5,000 right there, and we should start seeing some alerts coming in. We wanted to get one alert. It dropped down below 5,000 pretty quickly. Here's the first alert, and it says, the threshold is 5 seconds. The current value was 5.4 seconds, and looks like we're up there again. We should have some more alerts coming in. Yeah, so this is being triggered every 5 seconds, so we can get a detailed play-by-play. You can see the current value is 6 seconds, and then we just went up to 10 seconds and 16 seconds, and that's it. And so we're still up there in that range. Once it drops down, we'll stop receiving those alerts. So let's see. Yeah, still getting those alerts. Let that run its course. And here we go. So it dropped down, and now that's it. So you see, it got up to 30 seconds in that case. And again, I did that by setting a maximum bandwidth on this mirror, so we can make the async queue grow. So the last alert I want to demonstrate is, well, what happens if the mirror goes into a pause state? So in normal operating circumstances, the mirror is in a mirroring state, as we see here. But if the network becomes unavailable or someone reboots the target server, the mirror state will change from mirroring to paused. And so we'll see that. I can manually do that by pausing and unlocking the mirror. So that will cause the mirror state to change. And of course, we'll get a notification from SQL 1 that the mirror state of the source has changed. Previous state was mirroring, current state was paused. The reason the user paused the mirror. So if I go ahead and continue and lock the mirror, we'll see two state changes. We'll go from paused to a quick resync. Resync any data that changed while it was paused, and then it'll go into a mirroring state. So we'll see alerts for each one of those states come through here. So here's the alert here. The previous state was paused, current state is resync, and then finally it went from resync back into a mirroring state. So all those events were sent via email. And then lastly, if the cluster has a failure and it fails over, so right now we're running on SQL 1. If I move this to SQL 2, there'll be a series of events that are logged, which we're currently set up to receive notification on. So we'll start seeing a bunch of events come in. Essentially, there's two events, event ID 16, which is the mirror state event we just looked at, and then also the event ID 23, which is the role of the mirror. So prior to the switchover, SQL 1 was the source and SQL 2 was the target, but after we switched over, SQL 1 becomes the target and SQL 2 becomes the source. And so we'll see that in some of these 23 events. We'll say the role, previous role was none, the current role is target. So this is comes from SQL 1. It's telling us it is now the target of the mirror where it used to be the source. So we'll see a series of those events. SQL 2 will tell us and that is the source, and SQL 1 will tell us it is the target. So all these events are automatically sent, and so you can be notified should any failure occur in the cluster.